Hello. Today we're going to talk about 7.3 logarithmic functions. All right, so the first thing you need to know about logs is that they are actually exponents. Okay, so notice how I can write it in exponential form this way, and then I can also write it in log form. Okay, so it's just another way of writing it. N represents the argument, all right, what it equals here. B represents the base, and P represents the power. Okay, so how we say it in log form, we say log base B of N equals P. Okay, so whatever that B is, whatever that N is, whatever that P is. So log base B of N equals P. All right, so then using our common properties of exponents, right, we know b equals b to the first and 1 equals b to the 0. Anything to the 0 power is 1. So using those properties and converting it into log form, we get these rules. So when the b's are the same, though the base and the argument, then you get 1. When the base is anything and the argument is 1, it's going to equal 0. This is always going to be true, just like these two are always going to be true. All right, also when using a common log, the base is never written, much like an exponent of 1 is never written. So a common log would be like log of, I don't know, 36. All right, that's the same thing as saying log base 10 of 36. So a common log, you don't write the base, and if the base isn't written, it's base 10. Okay, most calculators are base 10. Okay, the log is base 10. Okay, so let's do some conversions first. Okay, so let's start by putting it in, going from log form to exponential form. So I always, all right, start with the log or the exponent on the left side. So log on left side. Then I do a loop-de-loop. I hit the base, the argument, the power, then the argument. Ooh, I said that wrong. So you do a little loop-de-loop. So we hit the 6 first, then we hit the 2, then it equals 36. Because remember, exponential form, all right, is something to a power. So we do a loop-de-loop to do that. All right. Try these next two. Do a loop-de-loop. So 2 to the first power equals 2. Do a loop-de-loop. Okay, a lot of people miss this one. The base isn't written. That's base 10. 10 to the negative 3 equals 0.001. Okay, we can double check them because look, 6 squared is 36. 10 to the negative 3 is 0.001, right? Put it in your calculator. All right, now if we want to go the other direction, so we want to put it into log form, so we want the log on the left side, so make sure the exponent is on the left. And again, just do another loop-de-loop. Okay, so log base 6 of 1 equals 0. 6 to the 0 equals 1, right? Your loop-de-loop should keep you, you can go back and forth. It's like a little dance. Okay, do the loop-de-loop. We hit the 8 first, so log base 8. Then we hit 1/4, and since that's a lot of numbers going on, I'm going to put it in parentheses. So you can put the argument in parentheses, equals your exponent. Do it again. Okay, don't be alarmed with all the extra stuff. You know what the things are labeled. So start with your base. So log base 5 of, so your argument, 5 square root of 5 equals the exponent, 3 over 2. Okay? All right, so let's step it up, okay? We can simplify numbers with exponents. All right, so now we're going to be able to simplify numbers with logs. Now, at first, that can be intimidating, right? Because logs are brand new, right? And they're very funky looking. So until we get used to them, I highly encourage you to put it as an exponent. Well, you may be thinking, but there's no equals. All right, well, it equals x, right? It's got to simplify to something, so let it equal x. Now we can do our loop-de-loop. So we do that, we get 5 to the x power equals 25. Well, that's easy to see, right? 5 squared is 25, so our answer is 2. All right, let's try another one. Okay, so this one, we'll let it equal x. We do our loop-de-loop. And we get 16 to what power equals 8? Well, 16, that's not, I can't make that, 8 squared, right? That's not nice. So let's adjust the 16 and the 8, right? We know 16 is 2 to the 4th. And we know 8 is 2 cubed. So we have 2 to the 4x equals 2 to the 3, or third power, sorry. All right, I know this one's a tricky one. Okay, I know it's a tricky one, but you got to know your properties of exponents. Remember how I said that was so important in chapter 6? Yeah, I wasn't lying to you. Okay, you need to know your properties of exponents so you can be successful in logarithms. So if you're struggling with that, come and ask me, and let's work on our exponents. All right. So now we have 2 to this equals 2 to that. So 4x must equal 3. So now x must be 3 over 4. So we simplified this to just simply 3/4. I know, it's a very weird process. That's why we're going to do a bunch of problems. We don't know what it equals, so set it equal to x. Do your loop-de-loop. And then we get 5 to the x equals 625. All right, we get out our handy-dandy calculator, and we realize 625, well, that's 5 to the 4th power. So x equals 4. Okay, so convert it to an exponent, and that'll make it easier. All right, why don't you guys try some on your own? So pause it, give it a whirl. All right, so I'm going to work these out. So I'm going to let it equal x. So we get 4 to what power equals 1 over 16. Well, hopefully you know 4 squared equals 16. And you should also know 4 to the negative 1 equals 1 over 16. So 4 to the negative 2 is 1 over 4 squared, which is 1 over 16. So this answer is negative 2. All right, this one is x, or let it equal x. There's no base, but we know it's 10. So 10 to the what equals 100,000. Well, hopefully we know that's just how many zeros you got to count. So that's just 10 to the 5th. So x is 5. All right, let's do another one. So again, the base is 10. Don't let that fraction throw you off. That's all the argument. So we get 10 to the what is 1 over 10. Hopefully you remember your negative exponents. They come up a lot. So that answer is negative 1. All right. Now, let's do some more. Let's see what happens if I put an x in a different location. Okay? So we still do the same thing. So now here we get 4 cubed equals x. You do your loop-de-loop. 4 cubed, just work it out. 4 times 4 times 4. What is that, 64? Perfect. This one, we do our loop-de-loop. X to the 4th equals 81. Well, 2 to the 4th is 16. Keep going up. 3 to the 4th is 81. So x needs to be 3. Okay, it's a lot easier to put it in exponent form. right? Once you start getting more comfortable with logs and the more often we do it, then you'll start to be able to solve these in your head and you'll start to realize, okay, x to the fourth is 81. But for now, you need to write your conversions, okay, until this becomes more comfortable. All right, so 15. So then we get 9 to the 3/2 equals x. Hopefully you remember that just stands for the square root of 9 cubed. Square root of 9 is 3. 3 cubed is 27. All right. Sorry, I know I just realized how fast I was talking. Not my intention. I just like logs. All right, let's do some more. All right, pause it, give it a whirl. 1/2 to the -2 equals x. So negative means you flip it, so this becomes 2 over 1 squared. So that just becomes 4 over 1, 2 squared, 1 squared. So the answer is 4. Here we get 7 to the y equals 1 over 49. So that should be 7 to the -2, because that's 1 over 7 squared, which is 1 over 49. So our answer is -2 here. Make sure you realize what you're solving for, that you put the right answer. Don't tell me it's 1 over 7 squared. Okay. The next one, 4 to what power is 256? Ooh, let's see. That's 4 times 4 is 16. Times 4 is 64. Times 4 is 256, right? 1, 2, 3, 4. So it should be 4 to the 4th is 256. Answer's 4. All right, let's see. Hopefully that makes sense. If not, come talk to me in class. I'd be happy to go and do a lot more problems.